Hello everyone, my name is Laura Villalobos, WiCyS Community Manager, and I'd like to welcome you to this WiCyS webinar with Abir from Flatiron on the topic Data-Driven Security with Unified Asset Inventory. But before we start, I'd like to introduce you a little bit more about the WiCyS organization. We often go by our acronym WiCyS, as in WiCyS, because that's exactly what we are, a global cyber sisterhood. We are a 501c3 with over 8.1K members in 70 countries. WiCyS is a premier organization with a global reach dedicated to bring together women in cyber. Our mission is to recruit, retain, and advance women in cybersecurity. All of our initiatives are made possible by our supported and strategic partners. We have our advocacy committee, mentor-mentee program, speaker bureau, job board plus, and so much more. You can view our trainings and initiatives on our website at WiCyS to learn more about different ways to get involved with the WiCyS community. All of our wonderful initiatives to our strategic partners, our tier 1 partners being Alchemine, Amazon, AT&T Cybersecurity, Battelle, Bloomberg, Carnegie Mellon University Software Engineer Institute, Cisco, Ford, Fortinet, Google, Lockheed Martin, Microsoft, Optum, India National Laboratories, and SentinelOne. As a friendly reminder, we encourage you to ask questions throughout the webinars. You can put them in the chat box, and the presenter will answer them at the end of the webinar. We have the experts here with us today, and they look forward to hearing from you. And then one last reminder, please make sure you subscribe to our WiCyS newsletter so you can stay up to date to any upcoming events and trainings. And you can do so by going to www.wicys.org and then subscribe. And with us today, we have Abir from Flatiron on the topic of data-driven cyber security with unified asset inventory. So I'll let him take it over now.
Hello, everyone. My name is Abir Hassan. I'm a senior security engineer at Flatiron Health. And as Laura discussed, I'll be discussing data-driven security with a unified asset inventory. So without further ado, let's get into it. Here's the agenda on how this talk will be structured. First, I'll introduce what Flatiron is, what my team does, and a little bit about myself. We'll go into the motivation for what was the motivation for creating this inventory, and then the design and implementation of it, as well as a demo with some real life use cases on how we use this inventory to answer some really interesting security risk questions. And time for Q&A afterwards. This is going to be a rather technical talk, so I encourage you to ask questions, but in the interest of time, please save them for the end. So first off, what is Flatiron Health? Who are we and what drives our mission? Flatiron Health is a company that was founded in 2012 with a mission to improve and extend lives by learning from the experience of every person with cancer. This is crucial to accelerating research and improving care. Flatiron's vision is to build a world where technology and science close the gap between care and research, where we are reimagining the infrastructure of cancer care. Flatiron's work today impacts over 4 million cancer patients by bringing therapies to markets faster, accelerating clinical trials, and improving the patient experience. Flatiron accomplishes this with their products and services like OncoEMR, which is an electronic medical record sold to community oncology practices across the US, providing de-identified research data sets, clinical trials, research partnerships with the FDA, and so much more. The security team's mandate at Flatiron Health is to secure PHI, that's protected health information, identify risks to that PHI, and communicate that risk to the rest of the company. So what's security engineering's role at Flatiron Health? The security engineering team helps with the security mandate by working on projects that automate security workflows, improve the security of DevOps processes, provides deployment pipelines so that other security verticals can easily deploy their tooling, and gather data that assists in risk-based decisions. Our team's unofficial logo, as you can see here, is a cat playing with a yarn ball, because our team is known for unraveling complicated technical knots for the rest of the security team. Who am I? I am a senior security engineer on the security engineering team at Flatiron. I've been at Flatiron for more than 4 years now, and this is my first job out of college. I went to NYU as part of a 5-year program where I studied computer science for my bachelor's and cybersecurity for my master's. And a little fun fact about me, my interests include rock climbing and gaming. So let's jump into the motivation for why we needed to create this unified asset inventory. So one of our company's values is start with why. So with any complicated problem, we should always start with why. And in today's complex security landscape, making informed decisions regarding risk management is crucial. However, a number of challenges exist that hinder this process. Here are a couple of challenges that we are running into as a security team, which led to the creation of this unified asset inventory. It was hard to make informed decisions on security risk facing assets across the company. There's a gap in the accuracy, completeness, and usability of several data sets that track physical and virtual assets. This being that assets can range from laptops, hardware that the company purchased, along with servers, software on those servers and laptops, and even network traffic. I'll go into further detail later, but all these different data sets are available in different portals, and it's all sporadic, it's all unstructured, and you don't know that it accurately represents your company's fleet. As I mentioned before, each data set has separate APIs and portals to interact with. There's no one-stop shop, no single pane view to get a good look on how the structure of your environment looks like. And you cannot view the data history that represents these assets with the different data sets available. You can only spot check what your environment looks like at the moment. So to further illustrate the problem, I'm going to ask some basic security questions that a security team would want to know, like the following. Where geographically are our employee laptops? Which hosts have antivirus? What do hosts in our cloud look like in terms of configuration? And what software has us, the security team, approved and denied? Well, here would be the answers to those questions. They can be answered by referring to their individual corresponding data sources. And again, I'll go into further detail on what these different data sources are. But it seems simple enough, right? Where our employee laptops, we use Jamf, which is a Mac management platform, but any company will have some sort of, any company's IT department will have some sort of management tool. Which hosts have antivirus? It depends on your antivirus provider. We use Cybereason. A lot of if you have a lot of what's the word? If you have a lot of hosts that need antivirus and you have uh, you have a contract with some sort of antivirus provider, they can have a portal that provides you that. What do a host in our cloud look like? We use AWS. A lot of cloud providers will allow you to view and configure how your servers look like, and what software has security approved and denied. Depends on how your security team does it. We have a internal review tracking portal. So it seems simple enough, right? Each question has its own corresponding place you get your data from. But if we dig a little deeper, we can see where the problems begin to arise. What if you need to answer a more in-depth question that would involve joining your sources? Like, what if servers have a critically vulnerable piece of software on them? Or what if there's unapproved software in your environment and you want to know which host that piece of unapproved software is on and what teams own them? The limitation of the current data sources is that when you do lookups in them, you can only see what they look like right now. If you need data from ranges in time, what if you need web traffic on X number of hosts over the past 6 months? Say there's an incident or you need to do some sort of audit. The current limitations of where you get the data from, does not allow you to do point-in-time queries. What if you need to make queries on a cadence? What if you need to make a snapshot of the network every week, or what's installed on servers and laptops for auditing purposes? Moreover, you don't know what the overlap of representation in your environment looks like between all your sources. What if you need to verify the coverage of your sources? What hosts have antivirus? Are they also logging? What's installed on them? You see here a very crude Venn diagram that shows like several different sources. You have hardware, which can include your laptops and servers, antivirus, which is like what's reported by your antivirus provider, and logging. This includes app logs, network logs, and they're all overlapping, kind of asymmetrical. It's messy because that's the point. Your environment is messy. Are all your hosts in AWS reporting to your antivirus management? Which ones are logging? You don't know what the Venn diagram looks like. And there are also more circles representing software in your environment, some which you may not even be aware of as a security team. How do you get a single pane view of all this information on your environment? And we found that there is no off-the-shelf um, vendor solution to getting a single pane view. If there was, then the security industry would have a lot fewer problems. But we've had to build our own custom inventory because of this. So with that, I'll move on to our unified asset inventory. So to solve these aforementioned problems, we created this inventory. It allows a single pane view of these important assets. It's unified in the sense that it combines data representing the same asset across multiple sources. Assets, when I say assets, I'm referring to stuff like Amazon EC2s, laptops, cloud logs, network logs, general host and physical virtual machine information, status of software installed across the environment, etc. It allows you to cross-reference between all these sources for one asset that's represented across all these different data sets. And essentially, all it is just a Python script that makes API calls to all these different integrations, normalizes them, and sends them to a Splunk index. We chose Splunk as our front end of choice due to the features it provides, but after I talk about its architecture, you'll see that the design is pretty flexible, so you can view this unified data in whatever you'd like. So it normalizes this data across different integrations, and it runs on a cron. Normalizing is important because you'll see sometimes that the same field is named differently across different sources. For example, you have source IP, internal IP, IP. Sometimes you'll have an external IP, so you'd want to differentiate. So you want to make sure all of your different sources are normalized correctly in terms of their name. Because it runs on a cron, you can get a point-in-time view on asset history because you're collecting what the snapshot of all your environment looks like at whatever cadence that you can choose. And this data can be exported and formatted for searches. So because it is a Python script that we've customized, we can format it to have the fields suit our use cases, which I will be discussing later. So now let's move on to the design and implementation. I'll be talking about the different integrations, its architecture, as well as enrichment with OS query and how we orchestrated this with FleetDM. So here are different integrations, some of which I've mentioned before. We have AWS, our cloud provider for our hosts, Jamf, a Mac management platform that the IT department uses, Cybereason, antivirus provider, Palo Alto Networks, our PAN logs, which is used for DHCP leases, which leases IPs to DNS names, lets you view network traffic. Unitsa, physical hardware purchased or owned by IT and thus the company, as well as Splunk, the status of Splunk logging across hosts in your network. If it has an API, we can programmatically ingest that data into our inventory. And our next integration is our security request portal. This is an internal web app that we use to track security approval. Employees would submit requests for stuff like third-party libraries, Chrome extensions, vendors reviews, etc. And it has a REST API, which allows our inventory to query data from it. So this request portal has a database that has all software and Chrome extensions and all libraries that security has programmatically approved and denied. We can use the REST API to programmatically consume this data and cross-reference it with what's on hosts, what's installed across laptops, etc. And here's the architecture. Adding a new integration is simple. It's scalable. You just add it to the list of API calls that the Python script makes across all of these different integrations. So you just make a call to the data sources API. At the Python level, you can format and normalize that data so its fields are consistent with all the other sources. It sits on in a Docker container that we've deployed to an EC2 instance. Can also be deployed as a AWS Lambda because it runs on a cron. But it being in a Docker container makes it pretty portable in case you want to run this concurrently or across several different hosts. Makes runtime environment not that much of a concern. And we post it to our Splunk cloud via HEC, which is the HTTP events collector. So it formats the events locally, or not locally, but like in the script. It formats all the data you get from the API, formats it, and then sends it to Splunk in the unified and normalized manner. So the advantages of this architecture, as I said before, it's portable. By being Dockerized and running on a cron, it can be put anywhere that can run Docker. Since events are formatted as JSON, it is platform agnostic. They can be posted to Splunk, as I've said, but they can also be posted to a database of your choice for viewing in case you want to make some sort of internal web app. If you want to publish this data via a REST API for your other organization's services to consume as well, you can do that too. It's pretty extensible in that regard. It's customizable in terms of its format. Your data can have the desired structure that you want and the reporting cadence that you want based on your cost needs or your information needs or your auditory needs. You can do it once per hour, once per day, once per week, once per month, and you can change this per integration. So you can have certain integrations reporting at different cadences than others. And if it proves to be a problem in terms of like Splunk cost or database costs, depends on the scale of your fleet. And we can choose how often the data is sent to the cron and make it different for each integrations. In the example that one integration would be dependent on another, you can make the dependent integration run more frequently. And as I mentioned before, it's scalable. It's pretty easy to add and remove integrations to it. So now I'm going to discuss how we enrich this data with OS query. Even with all of these different API integrations for SaaS services that the company uses, there can still be some gaps in host data. This is where OS query comes in. OS query is an open source framework published by Facebook that abstracts the operating system as SQL tables, where you can make queries such as select star from apps where name equals whatever and version equals something else. There's a giant list of tables that I won't get into, but it's pretty powerful in terms of what information you can provide and the ease you can query that across your fleet. You can cross-reference this host metadata with the existing data from the inventory, and you can answer targeted OS questions about hosts of interest, which is useful for triage, host performance, isolating processes, and applications, to name a few. So we've orchestrated OS query with FleetDM, which is an open source orchestration platform for OS query. If you just have OS query on your host, you'd have to manually make queries to hosts individually. So in order to make this more painless for a security team, if you want to answer questions about groups and hosts, we have this orchestration platform called FleetDM, which is previously known as Collide. This is an open source fork of the now paid version of Fleet. You can distribute ad hoc and or schedule queries to hosts in your company fleet based on criteria that you decide, like OS, group, labels, etc. We've set it up to automatically enroll new hosts in the environment by building in the OS query agent into our AMIs, which is AMI is a Amazon Machine Image. For those of you not familiar with AWS, it's sort of like a disk image that new hosts are spun up with. So we've built in the OS query agent to automatically have new hosts in the environment report to this orchestration platform. It uses common query packs, which are useful groups of queries that other security professionals have come up with and published. So these are groups of popular queries that people find useful, like, for example, service and port network traffic on a single host, groups of hosts. You can make queries in the front end to target specific hosts based on host OS or other columns in the table. You can apply custom labels to hosts. The enrollment installers are built into the AMIs, which I've discussed, and they're also automatically built into employee laptops when they're onboarded. So if there's a new host or server, laptop, new piece of hardware in the environment, we have eyes on it. It is reporting to FleetDM. And now this is what the architecture looks like now that we've enriched it with OS query. We've enrolled hosts and servers into FleetDM by having that OS query agent installed on each of them by default, and have FleetDM also report the results of its queries to Splunk Splunk Cloud as well. So it all being available in the same display is pretty useful, because now we can join on all of this data that's available to us. And we will see this in the demo when I discuss the use cases. So now let's move on to the demo. I'll talk about possible use cases for all of this data, methods that we've interacted with it as a security team, as well as some real life examples. So as I mentioned before, you'd want to track antivirus status on hosts, what applications are installed on hosts, where hosts are connecting from geographically, sudden changes in host location. For the example of stolen laptops, you definitely want to keep track of where your company property is in terms of security risk. Cross-referencing with vulnerability data as they get published, say new CVEs come out, alerting based on joining of this data, like if unapproved software gets installed in an environment, you can use it to provide evidence for audits. Say your GRC team needs to find patching status on groups of hosts, and much more. Here are the ways we interact with the data. If you have a search that you find yourself consistently making in Splunk, you can make a dashboard if you interact with that data often, and that dashboard will auto update based on the cadence that it's reporting to Splunk. An example is we have dashboards for Macs that are out of the country, and we can cross-reference this with travel approvals made to the GRC team in the security portal. You can have auto lookups if you find yourself joining data frequently between sources in the inventory, as well as other data in Splunk or other data in your front end of choice. You can have auto lookups automatically enrich the non-inventory data without you having to manually join each time. You can also always just make ad hoc searches for immediate questions you need to find out the answers for. and you can cross-reference. The main use of this is cross-referencing with all the other data sources, like, as I mentioned before, OS query, threat logs from your threat intelligence provider, and so on. So here's our first use case. Say you have an internally deployed tool in your cloud provider, in our case, AWS, which has redeployed many times over releases, that only a certain group of users are supposed to have access to. However, you discover that this is not the case and that your access controls are not working. How do you determine which unauthorized users access the tool, and over what period of time did they access it when the um, authorization controls were not working? So here I have a little crude diagram for groups of users. They fall into two buckets, authorized and unauthorized, making requests to your deployed tool over the history that the tool has existed. And as the tool gets deployed, its IP obviously changes unless you set its DHCP lease to static IP, but typically that's not the case. So how would you do this using this inventory data? Well, in conjunction with the application logs for the tool, you can look at your AWS integration, and because the inventory reports on a cadence, you can look up by name for the hosts that the tool is on, and you can get a complete history of all the IPs that the application has ever had. You can cross-reference this with the PAN, the DHCP lease integration, to find the web traffic history of all user IPs to all application IPs, cross-reference that with all possible IPs that the application had. And we have our Jamf integration, or your laptop management integration. Since user IPs can also change when they're on the VPN and off the VPN, off network, you can get an IP history of users and also look up by group if they were in the authorized and non-authorized groups. And using this in conjunction with your application logs, you can assist your incident response team to determine who requested what and when over the entire course of time when your authorization controls weren't working. So this is one very powerful way that we've used this tool. Here's another one. Oops, I went forward too much. Say CVE for a widely used binary across your company's assets are across your hosts comes out for a key piece of software in your tech stack. How do you quickly identify affected hosts so that you can remediate this vulnerability? Well, here we have made a query with OS query via Fleet. So we've orchestrated this one SQL-like query, select star from packages where name equals Ansible. I just use Ansible as an example here, but you can also, it doesn't have to be a Python package. It can be some binary, some piece of app that's some piece of software that's installed on your host. I just chose to use Ansible as an example here. So you use Fleet to distribute this query over the group of hosts that you suspect would be vulnerable, or you could just make it across all your hosts. So it would, this is what the Fleet UI looks like. It would respond with rows of hosts that fulfill the criteria of your query. Obviously, I have to redact the name of the host, but it'll show you all this information. And you can use this to get a list of host names so that you know what hosts have this piece of software installed. Okay, something happened when I imported these slides here. That's supposed to say relevant fields on the right-hand side. But for your AWS host, you can look up in the AWS integration in your inventory. After you've identified the host, you can get the owning teams from those host tags. For employee laptops, you can search with the Jamf integration. And then you can search in Splunk to identify the teams that own those hosts based on the tags as well as the instance team fields on the right-hand side. So this is what that Splunk search would look like. And since you have a group of hosts, you would have like host names equal to that list of hosts. And this is the type of information available to you. So now as a security team, um, you have what hosts have this are vulnerable to this CVE. So now you can prioritize your remediation based on antivirus and logging status of those affected hosts. So okay, I guess again it some formatting messed up, but that's supposed to say relevant fields for cyber reason on the right hand side. So here's an example for hosts that came out for a CVE. So we look up the host in the Cybereason integration. You have the list of fields for that that host on the right hand side. And in Splunk, as you can see, there were no events. So for these hosts, so in this example, the host has antivirus but isn't reporting to Splunk, which is cause for concern. So we'd want to prioritize the hosts that are not logging to Splunk, that are vulnerable to this CVE. So in remediating the CVEs for this host that are not logging, you're also aware that these hosts are not logging to Splunk. So you'd want to get it to report to your Splunk integration for visibility. And finally, our last real life example, tracking approval status for installed software. Obviously, as a security team, you only want to allow approved software to be installed on your endpoints. How do you determine who or what servers have installed unapproved software? Well, we have our security request portal as an integration in our inventory because of the REST API. It tracks all approvals and denials. We can cross-reference this with what applications are installed in Jamf and OS Query. So here I have Grammarly, a Chrome extension that our security team likes to use as a golden example of a Chrome extension you should deny due to the overly permissive permissions it has as a Chrome extension. It can read all traffic on all sites. It sends it to Grammarly servers, and it takes your cookies as well. So this is a very risky piece of software. And given Flatiron's use of PHI in browsers, this would be a high risk for a security team to allow for use at an organization. And even though Grammarly has its uses professionally, in terms of security risk, it is denied. So we'd want to make sure people are not installing Grammarly anyways, even though security's denied it. So we can, again, query that Grammarly is, see if Grammarly is installed on any hosts. But here I use Chrome extensions as example. It can be any piece of software that's denied. And you want to see using Flatiron to distribute this query across your fleet to see if that piece of denied software is installed on any host. And in this case, no, it is not, because we've worked with our IT team to automatically block unapproved software installations. But this can also, if you don't have any security controls in place with this, you can use this to verify the security controls are working if you have them, or use them to identify gaps in your security controls. If the denied application showed up in this query result, we would have a problem, which means even though we as a security team think we have this security control in place, this would provide confirmation that it is in fact not working. A denied application somehow got installed in the environment. So that's a pretty powerful use of Fleet to query for pieces of denied software that we've tracked in our security portal. So here are the next steps for this project. We want to make sure the data completeness for fleet enrollment accurately represents Flatiron's fleet in terms of window hosts and all AWS accounts. More accounts are getting spun up, so we want to make sure that OS Query enrollment agent is built into new hosts by default, as well as making sure we have an accurate representation of fleets in terms of operating systems as well. We're also always gathering more use cases for this data from other teams, and also more use cases for other teams outside of security, because this can also be used for stuff like tracking for infra across the org. And finally, the next step is to use this information to build a risk registry of everything in your fleet so that you can more easily communicate risk of your assets at a glance using the single pane view of your environment. So with that, that is the end of my talk. Thank you for attending this. You can feel free to add me on LinkedIn. Reach out to me if you have any questions about Flatiron security or this inventory in general, using the QR code on the left, and check out Flatiron's open opportunities on the right. And with that, that is it. Now it is time for any questions. So feel free to use the questions in the Bright Talk view on the right. I do see some questions have come in. So there's this one question: is this like ServiceNow inventory asset management with a single plane? Uh, yeah, so we explored a couple of options at the time of creating this. We elected to go with a custom solution because every organization is going to be using different SaaS platforms. They have a different environment, and these a lot of vendor tools or like open source tools, they don't fit the bill. There's no one size fits all. So like we have a lot of custom integrations, like I mentioned with the security portal. There is we've built that ourselves to internally manage security approvals. Of a third party or like a vendor solution wouldn't provide the use that you would have with that unless they'd also provide that management capabilities. So due to the unique nature of the different landscape of the environment, that's why we decided to go with a custom solution. But yeah, to answer your question, it is similar. It lets us manage the the single pane view of our assets with this. The next question is, do you have a solution for SQL injection, such as only use prepared statements? So I'm assuming this is in response to the OS query. So OS query is an open source framework contributed by a variety of security professionals used widely across the industry. It is prepared statements and SQL sanitization is built into it, using the sorry, excuse me. Uh, yeah, using the FleetDM orchestration tool. So it does escape and use prepared statements. Is this FedRAMP certified? I'm sorry, I don't know what that is. I can get back to you on that if you reach out to me afterwards. I'll just move on to the next question. Does Flatiron use AI capabilities? Um, I'm not at liberty to talk about that. I'm sorry, but I'll move on to the next question. Uh, Next question, kudos on the work on the asset management, one of the tougher problems to solve. Do you track end of life or support across applications and DevOps code? Not directly through the inventory, but as you discover like pieces of software go end of life through other means, you can use that information to look up for end of life software. And I don't really know what you mean by DevOps code, but in terms of like pieces of software that are on or piece of software and applications that are on your assets. Once you discover either through CVEs or through asset management, once you're made aware of that, you can use that information with the inventory. So it's not directly tracked with it, but it can be used for it. Next question was, one was the main driver in selecting your hyperscaler AWS? Historical reasons. So as I said, Flatiron was founded in 2012. So we've always been on AWS. So it's a much more heavier lift to just switch cloud providers than to just go with what you have and instead invest in the visibility in your existing solution. Because there's a yeah. Were there any transition issues into using the system, and how did you go about handling these issues? Great question. So in terms of transition issues, um, so as I mentioned before, the motivation for creating this inventory was that all the different integrations were available in separate portals. So for the use cases, um, that I mentioned before, with like looking up if something's vulnerable to a CVE. If we didn't have Fleet queried, we'd have to go into AWS one by one and look up each host to see if they have that package, see that if they have that piece of software installed and see that version. And it's just incredibly time consuming. Stuff with like Jamf asset management. If you want to look up user IP groups, you can only look at what their IPs look like at that point in time. You don't have that history. So in terms of transitioning to use this system, we went from looking in a bunch of different portals for information to looking at this one place in Splunk. We have had to learn Splunk queries and building dashboards and building auto lookups in Splunk by virtue of choosing our Splunk as our front end of choice. So we've had to go through some Splunk training as a team to better use this, as well as when we were spinning up OS query, we've had to deal with a bunch of teams in our engineering department to get on board with installing these agents by default. So I hope that answers your question. I am going to try to be a little quicker with answering these questions because we do have some. Okay, FedRAMP is compliance. No, it is not FedRAMP certified yet, but that could be something we could explore with our GRC team. Okay. Source code scan. Yeah, so I'm assuming this was for the previous question with DevOps code. Yeah, so static code analysis, vulnerability scanning tools are not directly included in the data available in the inventory, but it is as part of the future data sets and use cases that I mentioned before for next steps. It is being considered as our product security team considers different static code analysis tools. We'd want to automate the output of that and include that in our inventory. So yeah, that is an excellent use case for it. What forms of automation have you implemented in your security environment? So is this specific to inventory, or are you talking about for SecEng as a whole? Because I guess for the presentation, I've mentioned that we've automatically built in enrollment for the hosts into this inventory. But other forms of automation, I've built an automation that automatically re-reviews Chrome extensions when they're updated on the Chrome store. So obviously, like when you approve a Chrome extension for use across your org, or really any piece of software. It's done with a point-in-time assessment, but if that software gets updated, then there's a chance it could have increased in risk. So you'd want to automatically flag approved pieces of software time and time again for re-review if they have updated. As for inventory, yeah, it automatically fetches data from all these different APIs because it's built on a cron. So it is a Python script that make it's a bunch of Python scripts really that make different queries to all the API portals to all these different integrations. So as you see here, yeah, AWS, Jam, like all of these integrations, they all have APIs, and all of their APIs, all of their REST APIs are different. So we have a bunch of Python scripts that make API calls, API requests to those different APIs, formats them to be the JSON that we want, so to unify them. All these Python scripts run on a cron, they sit on a Docker image, and all those Python scripts they post those JSON events to Splunk over HEC, which is the HTTP events collector. Okay. I believe that is all of our questions. So once again, thank you for attending. This is my first time giving a talk like this. But yeah, feel free to add me on LinkedIn, reach out to me if you have any questions about this type of work. And I hope this inspires you to think more about unified asset inventory and using data to drive your security risk decisions. Thank you so much, and I hope you enjoy the rest of your day.